Hello everyone. So in today's class, we are going to discuss about graph theory. Well, graph, what it means is like we do have nodes or the vertices, and we do connect these node and vertices by edges, and it represents a relationship that how a node is related to another node if we do have an edge between them. So, if we solve a problem like taking all the equations and the approach like analytical or whatever in consideration, it will take a lot of time. But if you want to show relationship between variables, between features, it's better that we can apply the concept of graph, because if you do have some diagrammatic representation, it will be easier for everyone to understand. And graph is having a good weightage in data science and machine learning. That means if we talk about neural network, if we talk about decision tree in machine learning, decision tree, that tree is also kind of a graph. Okay, where we do have a root node and then we are having leaves. Okay, so decision tree is also a graph, and tree a special kind of a graph that where we don't have any close circuit. So it's that kind of a special graph. Graph can close also. Okay, we can see the closing in the graph also. It can have a circuit, and tree don't have a circuit. It doesn't close. So in decision tree we are having a graphical representation without a circuit. Apart from that, neural network, if I do talk about deep learning, so we do make the layers, and we do put neurons in the layers, and we do connect these neurons with each other. Obviously it's kind of a graphical representation only. Apart from that, we are having further more concepts like graphical neural network. Okay, and graph retrieval also. Okay, so the graph keeps very much important the way it solve a problem easy. If I need to show a relationship, if I need to show how data flows in a network, graph helps us in many ways. Okay, now let me share my entire screen and talk about the history of the graph, how it came, and the terms which are associated in the graph. Okay, so graph approach to data is to in commercial world, and it do talk about behavior of complex systems in a easy way. Okay, so in data science, machine learning, artificial intelligence, we do have a lot of use of graph. Okay, and what graph is? It's a representation. That means we do have the networks. They are represented with the help of a graph. These are complex systems. They do have complex connections. Okay, so these complex systems and the complex connections, can be represented with the help of a graph. For example, if I would say social network, we all are connected with each other. So, in order to make our relationship like how I can understand, so graph theory keeps important. Fine. So, like in this way, I will be having a diagram also ahead. So, if this is a common person between two people, A and B, you can see that it's a graph. This is common person, this is C. B do have its own network. A also have its own network. C also have its own network. However, with this particular edge, I can and this particular edge, I can find that C is a common friend between A and B. And this is how the mutual connection are recognized. Okay, mutual connections. Okay, can be find out by the social media. Fine. So obviously they use graph retrieval, graph techniques. Okay. And now to analyze the structure of representation, you can answer questions and make predictions how the system works and how individuals behave within it. That means in network science, we do use graph concept as a mathematical model to perform the analysis. That's what I told just right now, how the relationship has been there between the nodes, between the people. We are connecting them with the help of the edges and we can answer related to it. So graphs are mathematical representation of complex systems. Okay, to understand a complex system, it becomes very much difficult to handle the relationship between the data, to handle the relationship between the components, how to represent them. It's better that in a system I can make the nodes and I can have the edges and I can connect them. This is how I can represent. Okay, so graph it came in 1736. This concept, and it is related to a city of Königsberg. From this place, the concept of graph came into picture, where there are two islands which are connected to each other and the two mainland portions of the city by seven bridges. And this is a very famous problem. And it has been taught to computer science students in a subject that is called as discrete maths. I also studied this in my engineering days when I was in second year, I guess. There was a subject, discrete mathematics, and there was a chapter of graph theory. And this famous problem was present there. I am having two islands connected to each other, and there is two mainland also, mainland portions of the city. And overall, we are having seven bridges. And there is a puzzle. The puzzle is we have to visit all the four areas of the city connected by the seven bridges, only crossing each bridge once. That was a problem. Okay, you have to visit all the four areas of the city, but there is a condition. You have to use a bridge only one time. A bridge for one time. There are seven bridges, there should not be any repetition. Okay, so with this insight, a person named Euler, it established the groundwork for the graph theory. That means he is the first person who came up with the concept of graph. Okay, and he told that fine, you have given a problem and you asked to solve the problem. Okay, so what are the suggestions given by the Euler on this Königsberg problem? That means walking the bridges of Königsberg, there are four main areas and seven bridges. Can we cross each bridge once and return to the starting point? That was the question. So what the Euler gave the answer as the only relevant data in the main areas and the bridges connecting them, and that is like The Euler abstracted the problem and created generalized rules based upon the nodes and the relationship between them. Okay, and actually, this was the problem. You can see these are seven bridges: one, two, three, 4, 5, 6, 7. And a river is flowing. This blue one is a river which is flowing. So I am having four islands, okay, like this. Okay, and it can be converted into Euler inside. That's what the Euler gave. Just it's written above. The only relevant data, no? Only relevant data. That means I just want to talk about. Okay, you are saying the bridges, and you are talking about the islands. Okay, just that's what I want. That is the Euler inside, and then it converted into a graph. This is the graph. Okay, where I'm having four islands, and I do have seven bridges. You can see. So every node which is connected by an edge is a bridge between them. So I do have such bridges. Okay, and the problem is, okay, I can start from anywhere, no issue. I can start from here. I can start either from here, either from here, either from here. I can start from anywhere. But the question is, you have to go to each and every island, but the requirement is only one time bridge needs to be visited. There should not be any repetition. Fine. So the graph originated in maths, like with faithful representation of the data analysis. It represents network. I already told. It do have nodes and the vertices. Node or the vertices or the lines, they are called as the edges or the links or the relationship between them. That's what I told in the introduction also. Okay, so this graph of Koensberg, it is representing the relationship between these islands, how they are connected to each other with the help of a bridge. Okay, fine. So this is a way you can make the graphs or the plots. Okay, so this is a graph. When we are having a node and we are having a relationship, so the nodes are bigger. You can see this is a graph. This is also a graph. When I'm identifying or I'm showing a relationship between the nodes. However, the people do confuse. They don't know what is a graph, what is a chart, what is a plot. These are the plots. Okay, they also like uh, we say, okay, it's like putting here not graphs. Not graphs means like I am not having the huge nodes, and I'm not having any relationship between the nodes. I'm just marking the points here and connecting them. Okay, so these are actually the plots or the charts. Okay, that's what I can say, plots or charts. Okay, fine. So this is the equation whose plot or a chart is made. Okay, so by using machine learning and data science library also, no, what they say, matplotlib plot. It doesn't say graph, matgraphlib. No, the data visualization library is plotlib. Okay, graph. Okay, this is the graph where we do define the relationship between the nodes, and you can see the nodes are the big nodes, and here we are having the points. These are the points. Okay, these are the points. However, however, in simple terms also, we will say, sir, that's what we have studied from so long time, sir. They are also a graph. Yeah, they are been also put into the category of graph because there is no other way. There is no other way. But some basic difference, like now we have studied likelihood and probability. Same thing, graph and the plots. So these plots are over what certain axis. You can see there is xy coordinate. Okay, however, in you can see here, do you feel any xy coordinate here? No, I don't have any xy coordinate here. So when I need to show a relationship, there is a graph. But when I need to show the points, it's a plot. Okay, it's a chart. I can make pie chart, I can make line plot. They never said line graph. They never say pie graph. I hope this is for the first time you are going to have a knowledge about, okay, there is still a difference between a graph and a plot. Yes, I'm not putting graph on XY plane. Graph is simple relationship. However, I can put these things over XY plane. So if you ask any question to any of the person known to you among the students, that is there any difference between a graph and a plot? What is a graph? What is a plot? They don't know. In fact, your teachers also. Okay, fine. So these are the charts, chart of a budget. Again, I do have X and Y. In graph, I don't have. Okay, so yeah, defining graph. So like modeling graph is only half of the story. Graph in data science is been drawn to gain the knowledge to identify the relationship. Okay, and my theme of data science is this only, to identify the relationship in the data. That's why I'm learning data science and machine learning, to identify the relationship in the data, to analyze the patterns in the data. Okay, so graph graph basic measure about, that means if I do talk about the statistics, if I include the statistics, it is having the number of nodes and the relationship or the edges. That's it. That's what it is having. That's the stats which graph represents. That's the information the graph gives. Okay, and we do have many algorithms also related to the graph. I hope again, if I do come to the one of the subject in computer science again, that is analysis and design of algorithms. I also studied this subject, I guess, in second year. Okay, ADA. That's what we call as an ADA, analysis and design. There again the graph repeated, and we have used the graph in shortest distance algorithm to find the shortest distance algorithm, shortest path. Okay, I hope you're getting my things here. What I'm trying to say. Am I right, Arshita? Okay, Rohit is also saying that is she girl there because she is the right now student. Okay, Rajan sir also said. So these are the subjects, and where we have found that the shortest distance we do make a graph. For example, Prim's algorithm, Varshal's algorithm, okay, Floyd algorithm. So there are many algorithms. Where do we build a graph? Okay, but no one has told what is the difference between a graph, chart, and a plot. We consider all of them. Okay, ये सब graph ही है. ये भी graph है, ये भी graph. Both दोनों ही graph. Okay, अभी आपको now you came to know about this thing. What is the difference between them? Okay, so graph enhance machine learning and artificial intelligence application in form of a graph data, and it makes analytics much more easier. See, if you can represent the data, if you connect the data, if you have show the relationship between the nodes, okay, this obviously makes the things easier for us. All right, fine. So yeah, these are some applications. So I can use the graph in four different areas. Like I can check the movement. Okay, this is the movement. This is used for the influence. This is for the group interactions, and this is the pattern. Okay, so movement, that means I'm showing the direction. Influence, that means how the people are lighting up other people. Groups and the interactions, obviously you can see that how the communication is going on, and this is the patterns. Okay, the pattern can be of anything, any structure can be built. Okay, fine. So yeah, that's the point related to it. Okay, I do have many more part of theory related to the graph. Okay, so what they are saying, how do things move in a network? That's what you have seen: movement, propagation, direction. Okay, who are the most influential points present in a network? That means influencers. Okay, so influencers can act as a fast dissemination of the point. That means from which nodes the data flowing is being like, or the connection is the rate of flow of information is more, the connections is high. Okay, influencers. So such points, that means acceleration. Okay, so they are also being present. They can be represented by the graph. Okay, we can have the group interactions also, detecting communities, grouping the people, all these things like we can do with the help of a graph. Okay, pattern is very much significant because that's what we search in data science or machine learning. We uncover the network patterns. We try to reveal the similarities in the points. That's why we do explore our data. It's saying that data exploration. We try to find the patterns, relationship in the points. We try to find the similarity in the points. Okay, so that's what we do. So there also graph theory is important. Fine. So there are multiple applications of graph theory. Okay, including the algorithms. And we are using it from the longer time. Fine. So the rise of graph in data science, like it increase the ability to compute more data set, huge data sets, and it can have an awareness of the power of the graph to infer meaning and improve the forecast. See what we do in machine learning and the data science, we do have some common task. That means we perform the prediction or we do perform the forecasting. Okay, so with the help of a graph, it is saying that if you can identify the relationship between the data points, you can make easy way the forecasting. So there the graph plays an important role. Okay, and researchers, they play an essential role in developing such algorithms, such techniques. Okay, some like you would say some solutions. Okay, they are making the task very much easier. So as a data scientist, okay, the potency of structural information as they are increasing. So incorporating graph in statistics and in analytics is very much important. Okay, you are having a structured data, something which is present in form of rows and columns. That means tabular format. Okay, is there any way that I can simplify it? Is there any way that I can show that particular thing in form of a graph, some structure? Okay, so in fact, according to the Dimensions Knowledge System for research publication, the use of graph theory in AI research is accelerating. Okay, that's why I picked this particular topic. I considered this topic in my maths for data science and machine learning as one of the important topic. And there are many research papers, 700% increase related to the AI research. And now, as you know, the technology is growing, and AI is something where every industry, every organization is working on. Okay, fine. So that's what the case is. So AI application, where the AI application is, we can involve the maths, and we when once we can involve the maths, we are having a data, and once we are having a data, we can look out for how to apply a graph. So graph can be a part of healthcare. Okay, it can help in discovering the efficient drugs, some medicines, some solution related to it. Okay, which are inaccessible or something which is not been in our range, but however we can apply these techniques to have some good discovery. Okay, so if you are having a good knowledge about the graph, okay, it can integrate over 50 years of biomedical data and include genes, compound, disease, other information such as symptoms and side effects. We can have a good exploration. We can make a graphical representation or topology we can make, and we can try to identify the similarities. We can try to find the relationship. We can build a network structure. All we can do with the help of a graph. Okay, it's all possible. Fine. So that's one of the use case or the application that we, how graphs are helpful to us. Here also they did mention improving the patient journey. Okay, what factors are playing the importance over a period of time? We can have some graphical representation related to it, and then we can have some recommendations, some personalized marketing also. Okay, that diagram also I will show you that how a person is selecting a product. Okay, how it is related to it. We can have the correspondence. Okay, so making relevant product and service recommendation, that is correlating the product. That's what I'm saying. Customer information, history, inventory, supplier, all these things they require the graph. Okay, so the graph community detecting algorithms used to detect the customer behavior and the interactions, and we do make a project that's called as the customer, or I would say that recommendation systems. We do make a project, recommendation system. Okay, so graph theory is applicable there. Okay, graph analytics everywhere, either in a fraud detection in finance, also you can see. Okay, that means if we are having a regular pattern of the data, and if any pattern which comes across or beyond the regular pattern, obviously it's an anomaly. It's anomaly. Anomaly means it's an outlier. So, with the help of a graph theory, we can understand the network structure, and if there is something which is outside or behavior is uncertain, that's called as a fraud. Okay, so yeah, we can use the graph in fraud detection also. Okay, so here the application and some part of introduction has been mentioned in my tutorial related to the graph theory, and I do have another tutorial also related to it. Here is the tutorial. Okay, and the way graph introduced, already told you that in 1736 in the Prussian city Königsberg, a problem arose. Okay, and this is the problem: seven bridges, four island. Okay, and it has been told that like centered with two island. Okay, and these were connected with mainlands with seven bridges. Okay, they centered two island, and like seven bridges are there. Fine. So is my screen entire visible to all now? Fine, you can see. Okay. Graphs are very important. Do you have any project platforms? Okay, fine. So platforms you can recommend. Yes, sir. Yes, I will recommend. I will tell. Okay. So the story goes around like this now. I told. Um, while crossing an individual bridge, okay, you have to traverse each and every bridge once. You start from any point, but only one time you have to use bridge. Okay, fine. So following up this problem, while very simple to understand, the problem is very simple but difficult to solve. It's like a puzzle. And Euler was a person. Okay, the people do say that, sir, we are unable to find a problem. No, you are wrong. Actually, you are not looking around. There are many problems present in the world. You are not looking around. So this person looked. When it came to, when you get the information that, okay, this is something asked, he started thinking. Actually, you are not looking forward to think. All right. So the Königsberg bridge problem, also known as seven bridges of Königsberg, is a famous mathematical problem of 18th century. Okay, and this problem is named on the basis of the city only. Okay, fine. So the problem was to determine if it is possible to walk through the city of Königsberg across each of the seven bridges exactly once and return to the starting point. I already told you. You can start from any of the point. You can start from any of the island. You traverse each and every bridge, but it should be once and only once. And you have to return to the same starting point. That is a problem. So this laid the foundation of graph theory, which is a branch of maths. Okay. So here are the definition or the components of a graph. A graph, it is a data structure. Data structure, that means a way of organizing the data. And here we are organizing the vertices and the edges. That's what the graph comprises of, vertex and the edge. Where vertex are the nodes that are indivisible points. Okay, you can't break it. Okay, vertex can't be break, indivisible. Okay, and edge connects the vertices. one vertex to another vertex, edge is connecting them. We are having degree of the vertex also. Okay, degree of the vertex. That means the count the edges connected to it. For example, okay, these are the edges connecting to a vertex. Okay, degree is 3. We do have a parity, or the vertex refer to whether it is even or odd. Okay, depends upon the direction, because right now here I am not talking about the direction. I'm just saying that degree is the number of edges connecting to a your vertex. Okay, count the edges connected, but we are having degree also. That means how many outgoing edges and how many incoming edges. So in degree and out degree, that's what we are having. So this could be out, okay, and this could be in. So accordingly, parity will be decided. Refers to dv is it can be even or odd. That represents a parity. We do have a Eulerian path, that is important, because Euler, after getting a problem of this 7 bridges, he told that it is a path in a finite graph. Finite means, okay, that means we are having finite number of nodes and the vertices or the edges. Okay, that's a finite that visits each edge exactly once, allowing for revisiting the vertices. A Euler path is a path in a finite graph that visits every edge exactly once. So I do have a path where I will be visiting every edge once. That is a Euler path, allowing for revisiting the vertices. That means you can revisit the vertex, allowing for revisit the vertex. Okay, you can revisit the vertex, but every edge exactly once. Edges once, but revisiting of the vertex is there. Okay, so like now, this could be Euler path. If I start from here, I go to here, I go to here, and I come back here. So I'm revisiting my initial vertex, and I traversed each and every edge once. That's what it told, na? Edge should be once. However, you can revisit your node or the vertex. This is Euler path. Okay, the Euler path. All right. Now here is a graph. Okay, not talking about the Euler path. This is a graph. Vertex and the edges. That's you know. Now come back to the Prussia. What's the issue in the Prussia? Here is a map. You can see that there are islands. Okay, there are islands. These are first, second, third, fourth. Four islands are there, and this is bridge. This is also bridge. This is bridge. This is bridge. Bridge, bridge, bridge. You can start from any of the island. Okay, and you can visit these by bridges. The idea is, okay, you have to visit each and every bridge, but it should be for only one time, and you have to return back from where you have started. There is no repetition in the bridge visiting. Okay, so what happened? This is the way your Euler made. Okay, only the core part. Okay, this is only the core representation of the problem. Okay, and then finally it made like this. This is the graph, Euler graph. Okay, this is the graph given by the Euler. Okay, the graph of Coensberg bridge. A, B, C, D are the islands, and rest are the edges. Now, if you choose from your side that if I start from B, I go to A. From A, I go to C. Okay. Then from C, for example, I again come back to A, and see, I can't go to B now because it's been told that you have to visit each and every bridge. If you come back to B again, so you are again here on the starting point. It's telling that before coming to the starting point, you should visit each and every. Okay, so now if I came back again A, let me go to D, and from D, if I come here B, then this H is I haven't visited. Still, my problem is not solved. And if I go to this H, I will come here. I will come here, and rest I have already visited. So I'm trapped here. This is trapped. I'm trapped. Okay. So you start from any of the island, start from anywhere. Definitely you will be trapped. This is not possible. With the help of graph theory only, Euler explained. This is not at all possible. You will be trapped any of the vertex or the node. Okay, fine. So now here some try or the efforts has been done, but no one is able to give the solution. Okay, so working through example walks like one we have done. Okay, so what the Euler told about such kind of problems. See, Euler realized the heart of the problem concerned with the parity of each vertex. That's what I just introduced now about parity. Okay, that a traveler mid walk would always need an entrance and the exit edge from the vertex in order to continue their walk. So even parity is also needed to in order to continue the walk. That means in any of the vertex there is an entrance and there should be exit. Okay, there should be entrance and there should be exit. So parity is important. That's what it decide. I already told you above now that we can have an incoming edge, we can have an outgoing edge from any of the vertex. That's what I told above, just above I told. That's the parity. Incoming and the outgoing edge. That's the parity. So Euler told that okay, the heart of the problem is every node should have this facility. Then only we can solve a problem. Such kind of problems. So even parity. Why even? Is always needed. Why even? Okay, there should be one incoming and one outgoing. So there should be two edges should have to be there. So two means it's an even. It can be four also. It should have four also. But it generalized it told even parity. Every node should have an even parity. Okay, so therefore a traveler attempting a Eulerian walk along a graph must follow this thing. Graph should have to be connected. Graph must have exactly 0 or 2 vertices of odd degree. Either 0 or 2 vertices of odd degree. Odd degree means um, like you know it, odd number of edges. That will be the odd degree. So either okay, graph must have to be connected. That means there should not be any disconnection. Second, it is saying that either the graph has 0 or at least 2 vertices should be have of odd degree. Additionally, if the graph has two vertices of odd degree, then the walk must begin on one and end on the another odd vertex. If your graph is having even, okay, fine. But if your graph is having odd, there should be definitely two odd vertices. वो बोल रहा है मैंडेटरी है उसका कंक्लूजन है that's the conclusion of Euler what he how he tried to solve the problem, that what is the requirement to solve a problem, such kind of problems. He told that the graph should have to be connected and there should be at least either 0, okay, that means no vertex of odd degree, that is 0, or either there should have at least two vertex, there should be two vertex of odd degree. Okay, there should be two vertex of odd degree. Okay, and also we should start from one and end at one, only odd. That's what the Euler suggested. That's a Euler rule. Then only we can have a Eulerian walk. Okay, fine. So very important concept. And if we check this, okay, the problem which is given to us, does it follow? Does it follow? The degree of this node is 3. The degree of this node is 3. The degree of this node is 4. The degree of this node is 3. Euler told that I should have only two nodes of odd degree. However, here I am having one, two, three nodes of odd degree. So, according to the terms of Euler, since this graph is not satisfying the condition, how can I solve this problem? If the condition of Euler is solved, then I can traverse a graph. But here it is not satisfying. So, you can start from anywhere. You will be trapped straightforward. No issue. Okay, fine. So, yeah, that's what the graph and the Euler says. Sir, A is having 5 degrees. Yeah, you can have 5 degree. Yeah, you are correct. There is one no, between वो बीच वाली है 5 degree. 4 नहीं है अभी 5. 5 there is one more ना 5. ठीक है तो इतना सारा odd है. Every node is odd here. Okay, so Euler told in a basic way that okay, if you are having the nodes, it should have one entry and one exit. Okay, so for example, I go from here, I can exit from here. Then this is entrance of this node, and this is the exit of this node. And then again, this is the entrance of this node and exit from this node, and so on. I can come back. This is Euler walk. Condition satisfied. Okay. However, here the condition is not satisfied. So I can't have a walk. That means which you are asking for. Okay, fine. So yeah, these are the applications. The world of graph is growing so much. Okay, I already told you that you're using in data science. You're using it in machine learning just to analyze the data, representation. Okay, network information. You make the network, no? Okay, so in modern applications of data science, this gives very much importance. We are going to analyze social network, economic network, biomedical network, information web, internet, network of neurons. So yeah, that's what I told, na? Deep learning, network of neurons. You make an architecture, neural network of neurons are there. And also we use this graph theory in development of numerous foundation algorithms like Google page rank to Netflix content recommendation system. And the recommendation system also I told. Okay, so how one node is related to any other node, that's a recommendation system. Okay, so if I'm searching for movie like Spider-Man, okay, in movies database, it should give me the recommendation Spider-Man 1, Spider-Man 2, Spider-Man 3, Spider-Man 4, whatever be the series of movies were built on Spider-Man, it should show that. Okay, that's what the recommendation came. So Spider-Man is related or linked to all these movies. Na? I can use a graph theory. Okay, and here are the simple definitions of the graph. That's what we have already studied. Okay, vertex, edge. Okay, so this is a graph. Okay, and if I'm having the direction, then this is a directed graph. Okay, direction, then it's a directed graph. And if I don't have a direction, then it is undirected graph. Simple connection. This is undirected. This is directed. Okay, so here we can tell in a directed graph because the edges have the arrows in them indicating the movement from one vertex to another vertex. Okay, so this means that edges which are written as a pair of vertices must have a specific order. Okay, so here it is D to C. D, C. This is how you have to make an order. But you can't make C to D. This is wrong order, wrong. The edge is showing you the direction. You can go from D to C, but you can't come back from C to D. No, it's not possible. So D to C is correct order. That's what you have to maintain. Okay, writing D to A. Okay, let's check. Huh? Yeah, you can go from D to A, but you can't write A to D. This is not possible. There is no edge, edge between from A to D. So that's what you have to write. Okay, understood. Fine. So this is a directed graph. An undirected graph, okay, there is no issue. There are no errors, so there is no issue. You can connect anything and you can write any order. Order is not at all issue there. Okay, fine. I hope you understood the introduction of graph theory. And I will be referring to some more stuff related to the graph theory. These are the concepts which are used in our data science. I've told you about the applications. So in application point of view, I'll let you know at how we are doing this work. Recommendation system project is one of the best example. All right, so we'll check ahead related to it. All right, fine. Now, okay,